Hello, Algebra 2 students, and welcome to Lesson 1-6. This lesson, we're going to review how to solve systems of equations, linear systems. So our first method is by substitution. So here's a review of the steps. When you have a system of two equations, you want to take one equation and solve for one of the variables. In the next step, we do a substitution. So we replace that variable with the expression, and then we solve that equation. Once we've solved for one of the variables, we can plug that variable back in to find the other variable, and then we check our solution. So let's start off with an example. Example 1. Now the first step is already done for us, which is nice. Right here we have y is equal to 3 plus x. So I'm going to take the first equation and I'm going to replace y in the first equation with the 3 plus x. So my new equation becomes x plus 3 plus x is equal to 5. So when I combine like terms, I get 2x plus 3 is equal to 5. 2x is equal to 2, so x is equal to 1. Now we're ready for the next step where we do the substitution. So I can go back to either equation. I think this one's easiest because it's already solved for y, and I'm going to plug 1 in for x. So I get y is equal to 3 plus 1, which is 4. So my final solution, if you remember, this stems from what we just did with the graphing. Graphing would be another method for solving. Okay, we could graph these two lines if we had them both in the form y equals mx plus b. We could graph them and find the point of intersection. So we write our solution out as a point, as a coordinate, just like you did before when we were solving the problems in the last section. So x is 1, y is 4, so our final solution is 1, 4. Example 2. So let's see. Here we need to solve for a variable. And what I look for is there one where the coefficient is 1? And right here in the first equation, x has a coefficient of 1. So that's going to be the easiest one to solve for. So if I move the 3y to the other side, I get x is equal to 7 minus 3y. Now I'm going to take this equation and I'm going to replace this x with that expression. Okay, so I end up with 4 times. I want to put parentheses so I remember to distribute. So 4 times 7 minus 3y. And then minus 2y is equal to 0. When I distribute, I get 28 minus 12y minus 2y is equal to 0. And I think this time I'll combine the y's and move them to the other side to make it positive. So I'll leave the 28 on the left and add 14y over to the right. Solving for y, I get y is equal to 2. And now I can go back up to this equation and plug in the 2. So I get 7 minus 3 times 2, which is 7 minus 6, which equals 1. So my final answer, again, is x comma y, so 1 comma 2. Oh, the checking part. So let's check. You can check by plugging back in. Okay, so we have, let's see, 3 times y, so 3 times 2 plus x, so plus 1 is equal to 7. Is this true? Yes, because this is 6 plus 1, so that works. In the second equation, I have 4 times 1 plus 2 times y, which is 2 times 2. Oh, I'm sorry, that should be a minus minus 2 times 2, does that equal 0? And yes, it does, right? We get 4 times 1 is 4, minus 2 times 2, it checks out. Okay, so going back to the first example, if we check this one, we have 1 plus 4 equal to 5. That's true. And then y is 4. So we end up with 4 is equal to 3 plus 1, and that is true. Okay, example 3. Again, this equation is already set up for us. It's solved for x, so let's replace this x with the 3 minus y. So I have 3 minus y plus y equals 7. Look at this. The y's are going to cancel each other out. And I end up with 3 equaling 7. Do you remember what this means? If you said there's no solution, that is true. So there is no solution to this system of equations. Now, do you remember what that means graphically? Let's rearrange these. I'm going to add the y to the other side and subtract the x. So if I rearrange this to put it into y equals mx plus b form, I get y is equal to negative x plus 3. If I rearrange this equation, I'm going to subtract the x, leave the y on the left, and I get negative x plus 7. So if you look at both of the slopes for these lines, both slopes are negative 1. So that means that these lines are parallel. So when I ask the question, do you know what this means graphically? If you said that there's no point of intersection, that's correct. Okay, so anytime we have parallel lines, they do not meet, which means there's no point of intersection, which means there's no solution for the system. Example 4. Okay, let's see. We need to solve for one of the variables, so let's solve for y in the first equation because its coefficient is a 1. So if I subtract the 2x, I get y is equal to negative 2x plus 4. So now I'm going to take this and replace the y in the second equation. So I end up with 4x plus 2 times negative 2x plus 4 equals 8. So now I have to distribute that 2. So I get minus 4x plus 8 equals 8. Now look what's going to happen here. Again, 4x minus x cancels each other out, and we end up with 8 equaling 8. Now this isn't like the last example. The last example, we had 3 equaling 7, right, which doesn't make sense. Here we have 8 equaling 8. So do you remember what this means? If you said that there are infinite many solutions, or all solutions, you're correct. Okay, this means that there are infinitely many solutions. So do you know what that would mean graphically? Let's rearrange the second equation. If I move the 4x to the other side, and then I divide by 2. Right, I'm dividing every term by 2. I end up with y equaling negative 2x plus 4, which is exactly what I have here, right? Which means these are the same two lines, which means all points on that line are solutions. So there's infinitely many points on a line, so there's infinitely many solutions to this system. Okay, word problems. So we have the admission fee at a small fair is $1.50 for children and $4 for adults. Excuse me. On a certain day, 2,200 people enter the fair and $5,050 is collected. So how many children and how many adults attend or attended? So let's start with defining our variables. So we can let C equal the number of children. And we'll let A equal the number of adults. You can use any variable you want. You could use X's and Y's if you prefer that. I sometimes like to use letters that remind me of what I'm letting them equal. Okay, so I have less to think about when I'm done the problem. So let's see. Now what we're going to do is set up two equations. For problems like this, one equation is going to be related to the number of people. The second equation is going to be related to the amount of money collected. So if we know that 2,200 people entered the fair, then we know that the number of children plus the number of adults is equal to 2,200. That's our first equation. Now the money part, remember, it's $1.50 for children. So $1.50 times the number of children would be that amount brought in for children. It's $4 for adults, so $4 times the number of adults would be the amount brought in for adults. The sum of those two is equal to the $5,050. That's the total amount collected. So there's our system of equations. So I'm going to take the first equation and I'm going to solve for C. So I get C is equal to 2,200 minus A. And now I'm going to go to the second equation and replace C with that. So I end up with 1.5 times 2,200 minus A, and that was my substitution for C, plus 4A equals 5,050. Okay, so let's see, 1.5 times 2,200, that would be 3,300 minus 1.5A plus 4A is equal to 5,050. Okay, now I'm doing 5,050 minus 3,300. I have to borrow. So I get 1,750. And when I combine these, 4 minus 1.5 is 2.5. And now I need to divide 2.5 into 1,750, some good old long division, right? I need to move my decimal place over 1. So 25 goes into 175 7 times. So I end up with 700. Okay, going back to this equation. If C is equal to 2,200 minus A, then it's 2,200 minus 700, which means the number of children is 1,500. Right, 22 minus 7. Okay, so to answer the question, how many children and how many adults? So that means that there are 1,500 children and 700 adults. Okay, the next example. Here we have an exam. It's worth 145 points and contains 50 questions. Some questions are worth 2 points, some questions are worth 5 points. So I'd like you to pause the video and set this question up and solve. Okay, so let one of your variables represent the questions that are worth 2 points. Let the other variable represent the questions that are worth 5 points. And follow what we did in the previous example. One equation will be about the total number of questions, and the other equation will be about the total number of points. So go ahead and see if you can set that up and solve, and then come back to the video when you're done. Okay, let's see how you did. So I let x equal the number of 2-point questions and y equal the number of 5-point questions. So since there's 50 questions total, x plus y equals 50. So for the 2-point questions, that's my x. So 2 times x plus 5 times y for the 5-point questions equals the total number of points. So there's our system. I took the first equation and solved for x, did the substitution, solved for y, plugged back in, solved for x, and then wrote out that I would have 35 questions worth 2 points and 15 questions worth 5 points, which gives me that total number of 50. Right, from the first equation, this would be 70 points. 15 times 5 is 75 points, giving me that total of 145 points. So you can always check your word problems as well, right? Make sure they make sense. But this part is the answer to the question. Okay, we have one more related to animals in a barn. So we have 13 animals. Some are chickens, some are pigs, and we know that there are 40 legs in all. So how many of each animal are there? So go ahead again, pause the video, set this up and solve, and then come back when you're done. Okay, let's see how you did. So I let C equal the number of chickens and P equal the number of pigs. There's 13 animals total, so C plus P is equal to 30. Chickens have 2 legs, right? So 2 times the number of chickens. Pigs have 4 legs, so 4 times P. The sum of those two is equal to the total number of legs, which is 40. I took the first equation, solved for C, did the substitution, then I solved for P. After I had P, I plugged back into the first equation, this one here. So C plus 7 is equal to 13, which means there are 6 chickens. 6 chickens means there's 7 pigs. So there's my total of 13 animals. If there's 6 chickens, that gives us 12 legs, and 7 pigs gives us 28 legs, and then adding them up, I get 40 legs. So again, you always want to plug in and check, but your final answer is the number, how many there are of each type of animal. So that concludes the first part of this lesson, okay, where we solve by substitution. Next lesson, we'll look at the elimination process. Okay, I hope you enjoyed the lesson. Enjoy your day.